Okay, so for this video, before we discuss laws of motion, we'll be tackling first the different prerequisites for laws of motion. These are very important concepts that you need to understand before going with the three laws of motion. Okay, so for our objectives in this video, define inertial frames of reference, differentiate contact and non-contact forces, distinguish mass and weight, and then draw free body diagrams. What do you mean again when we say that motion is relative? If you remember in our past discussions, when we say motion is relative, it depends on the point of view or the position of the observer. If the observer determines that it's moving, there's motion. Pag hindi, hindi. So again, depende siya sa point of view or sa frame of reference ng observer na meron tayo. So what do you mean by inertial frame of reference? If we're going to strictly differentiate it, define it, I mean, also known as inertial reference frame, inertial frame, or Galilean reference frame, or inertial space, all are in a state of rectilinear motion with respect to one another, thus acceleration measured with any of them will reach zero. It is static or moving at constant velocity relative to all other reference frames. What it's clearly saying is that when you say that acceleration will reach zero, you have to explanation for that one. When we say that acceleration is zero, either there's no movement at all, that the distance, the velocity is zero, or either the velocity is constant. Remember, if you have a constant velocity, your acceleration will also reach zero. So these two instances that might happen either shows you that there's motion or there's no motion. But again, it will depend on the frame of reference na magli-lead ng acceleration mo is zero. Okay? So, how can we say that an object moved? Remember, this is the descriptors of motion when you have your displacement, velocity, and acceleration. Now, the question now is, why does an object move? An object moves because of your forces. Okay, so these are the forces that we're going to be discussing for this video. You have your contact force and non-contact force. From the term itself, for contact force, there's a physical, contact from the term itself nga with the forces. For non-contact force, wala siyang physical contact. So let's begin by differentiating the two. Okay, when we say contact forces, again, types of forces that result when the two interacting objects are perceived to be physically contacting each other. So examples of this one are frictional forces, tensional forces, normal force, air resistance forces, and applied forces. So let's discuss it one by one kasi kailangan to sa free body diagram. If you can observe here, this is a moving box siguro, and then you can see the red line is a pushing force, and then the opposite line between the surface is a friction force. The friction force is the force exerted by a surface as an object moves across it or makes an effort to move across it. It can be static or sliding friction. For example, when you're walking, for example, you're writing in a pen, using your pen in a sheet of paper, so there's a friction force there. Kasi sa surface yung pinag-uusapan natin. Friction force is not all, though it is not always the case, friction force often opposes the motion of an object, but it depends upon the nature of the two surfaces, upon the degree of which they are pressed together. So as you can see here, it's horizontal, wala naman siyang inclined na plane. However, if it's an inclined plane, the friction force will either increase because of your gravities or decrease depende naman sa kanyang orientation. So that's friction force. Very self-explanatory. Next is your tension force. Now, tension force oftentimes is connected with a string, rope, cable, or wire when it is pulled tight by forces acting from opposite ends. So, as you can see here, there's a wheel, goma, attached by a rope, and then since it's hanging, the tension force is with the rope, while the weight of the wheel is going downward. Okay? So, yung tension force ay nasa rope or string. Next, for tension force again, it is directed along the length of the wire and pulls equally on the opposite ends of the wire. So there's an effect. Either the wire is too long or too short. Of course, tension force will vary as well. Also, it will also vary depending on the weight of the object that you have and the type of material that you have. Okay, anyways, you know the context already. Next is normal force. Now, from the term itself, normal, it is often seen when there is a contact with another object or a physical contact with another object or a surface. Okay, so it's support force exerted upon an object that is in contact with another stable object. For example, you're sitting down, there's a normal force there. Kasi kung wala kang normal force, mahuhulog ka sa upuan mo because there's no support force, okay? And in terms of orientation of the normal force, it depends whether the object is, inclined in a plane or sitting down or lying down. Depende sa orientation niya. So the normal force will also depend on its orientation. So you can see here on the image. Okay. Next is air resistance force. Air resistance is a special type of frictional force that acts upon objects as they travel through air. So it's a special type of frictional force, and it is also a contact force because the air is generally in contact with your body or the object itself. So it is observed to oppose the motion of an object. Usually, this is seen in falling objects or in your projectile motion, but the air resistance is no longer that important in problem solving. Negligible na yung air resistance. Otherwise, it's stated na mayroon siyang effect. Pero sometimes it's very minimal that we don't usually use it para hindi tayo mahirapan in predicting the value. And it's most noticeable for objects that travel at high speeds or for objects with large surface areas. For example, as very small na pebble, pag inulog mo siya, wala masyadong effect yung air resistance. Pero pag gumamit ka ng sheet of paper and then you drop it on a very high building, of course, air resistance will come to play because of the large surface area of the paper. Unless it's crumpled, right? So it will vary. Okay, so that's it, I think. No, the last one is for the applied force. Applied force is the force that is applied by an object, by a person, or another object. If a person is pushing a desk across the room, then there is an applied force acting upon the object. The applied force is the force exerted on the desk by the person. So, just imagine, push or a pull, applied force yan. Pag nag-kick ka, there's an applied force. Common sense, applied to an object, or another object or another person. That's your applied force. Anything that is applied. Okay? And then lastly, you have your non-contact forces. The difference, again, from what I've mentioned is that there's no physical contact with each other, yet they're able to exert a push or a pull despite their physical separation. An example of this one is the gravitational force, electrical force, and magnetic force. Since we're talking about Newton's law of motion, what we're focusing on is gravitational force. For electric force and magnetic force, that is for physics 2. Okay? Now, for gravitational force, basically it's the force of gravity is the force with which the Earth, Moon, or another massive large object attracts another object towards itself. This is the weight of the object. Again, this is what holds us down and not let us fly through space. Gravitational force, all objects upon Earth experience a force that is gravity that is directed downward towards the center of the Earth. Okay, so these are the types of forces. You have your contact and non-contact, and under them you have your different type of contact forces, and then for non-contact forces. Okay, next let's differentiate mass and weight. Now, when we say I have 1 kilogram of rice, what is the mass and what is the weight? So how much does it weigh? So pwede kang magsabing 1 kilogram kasi oftentimes in layman terms when we say weight, sabi natin pag sinabi mo 1 kilogram, 1 kilogram yung weight niya. But if we're going to be strictly in terms of the definition, 1 kilogram is not a weight. Okay? A kilogram is a unit of mass, therefore, it is a mass. While your weight is 10 newtons. Saan po ito nanggaling? Okay? Before I think I can discuss this already. Okay. Newton is the unit of weight. Okay, in this case, we can already go about our definition of force, okay? So, Newton is the unit of weight. Force is equal to mass times acceleration. Mass is kilogram, while acceleration is meter per second squared. Ang 1 kilogram meter per second squared is equivalent to 1 Newton. Well, so Newton is a type of force. Newton is the unit for force. Okay, so balikan lang natin ulit yung definition. Kilogram is a unit of mass, so 1 kilogram is your mass. While Newton is the unit of weight. So dito, 10 newtons yung weight. Paano siya naging ganito? Remember that force is equal to mass times acceleration. Mass is the 1 kilogram of rice. Your acceleration, let's just assume that is 10 meter per second squared. Kasi 9.8 lang naman yung acceleration due to gravity if we're talking strictly about the moon. Thus, you can say that the force is 10 newtons. Or basically, that is your weight. So, we can say that weight is affected by the gravity. However, di man kita nagsasabing mabakal pong 10 newtoning bagas, right? Because oftentimes, you're already used to saying 1 kilogram of mass. However, yung 1 kilogram of mass na yan ay already affected by your gravity. So, in terms of your location right now, if you're on the Earth, your mass is the same in terms of your mass in the moon. However, your weight, because it is affected by gravity, pwedeng mas magaan ka in terms of weight sa moon. Kasi iba yung gravity doon compared sa weight sa Earth. Pero parehas lang ang bigat mo, ang mass mo, pero yung weight mo which is affected by gravity will differentiate depending on your location. So I hope this one is clear, okay? So mass versus weight, mass is basically more fundamental than weight. It's a measure of amount of matter, depends only on the number and kind of atoms that you have. For weight, it's a consequence of gravity, depends on the where the object is located, and gravitational force that acts on the material. And remember, for weight, since the unit is Newton, basically when you want to solve the weight, it is just mass times the gravity. Okay, galing lang naman siya dun sa definition ng force na mass times acceleration. And the gravity here is the acceleration due to gravity. Wait, naka-record pa ba ako? Alright. So let's proceed with free body diagram. Now, free body diagram is very, very essential or very, very essential, di ba? It's important in terms of problem solving that requires different orientations. Halimbawa, hindi na siya straight line, it's a two-dimension, there's an angle involved, the orientations is somewhat difficult to understand, or problem solving requires different sets of, focus. So, free body diagrams are diagrams used to show the relative magnitude and direction of all forces acting upon an object in a given situation. The size of the arrow in a free body diagram reflects the magnitude of the force, and the direction of the arrow shows the direction that the force is acting, and each force in the diagram is labeled to indicate that exact type of force. So you can see here, itong tatlong ito po, yan yung pinaka prerequisite in making a free body diagram. The size, the magnitude, the direction, and then you have to label them. If you don't follow this one, it cannot be considered a free body diagram. At the same time, it's like vector addition in a sense because you're going to show kung ano yung parang lalabas na final na free body diagram niya with respect or with the consequences of the forces present. For example, sige, hindi na lang yan para hindi tayo mahirapan. For example, a book is at rest on a tabletop. So if this is an actual, gagawa muna tayo ng actual, right? Gagawa tayo ng actual. This is a table. Yeah, illustrator ka, girl. And then this is your book. Okay? So that's your actual, right? But if we're going to make a free body diagram out of it, so if this is your book, isa siya yung book natin, right? At rest lang naman siya, you have your gravity because it's going downward, F of gravity. And of course, in the type of force that you have your normal force kasi hindi siya gumagalaw. May friction ba? Wala, kasi it's at rest lang naman. So generally, that will be your free body diagram. So very easy in terms of your actual and your free body diagram. Okay, next, let's have an example. A gymnast holding onto a bar is suspended motionless in mid-air. The bar is supported by two ropes that attach the ceiling. Diagram the forces acting on the combination of gymnast and bar. So, kung gagawa tayo ng actual, again, gawa tayo ng actual kasi gusto ko mag-drawing. So, if this is the bar, tapos, yan si gymnast. Yeah. Ayan, nakahawak siya dyan. Okay? Kasi suspended motionless daw siya in mid-air, probably stretching. How do you make your free body diagram? So, let's make the free body diagram. This is the gymnast. This is the hands of the gymnast onto the bar. And then, this is the weight of the gymnast. So, F gravity, going downward. This is your tension force. Kasi yung arms mo, technically, your arms is, there's a tension in your arms and the bar. So, pati ito, F tension din siya. So, tingnan natin kung tama yung answer natin. Ayan. So, F tension yung lalabas sa kanya. So, that's it. That's basically it. Sir, meron ba tayong friction? Wala naman kasi hindi naman kailangan. Ito yung pinaka-important na mga forces na meron tayo. So next, a flying squirrel is gliding from a tree to the ground at a constant velocity. Consider air resistance. So kung gagawa tayo ng actual, drawing tayo ng squirrel. Ayan. Squirrel. And then, it's gliding down at a constant velocity. Consider air resistance. So, it will be the free body diagram of this one. Since there's air resistance, so we can say that going upward is air resistance. And then, going downward is air gravity. Wala naman pong wing flap, so wala tayong force applied. Yan lang, air resistance and gravity. May normal force ba? Wala, because it's on, it's suspended in the air. It's gliding on the air. So wala siyang other na forces involved. So these two lang po ay enough na to show that the free body diagram of this one. So here po, I think this is in your reading material. You can answer this one already. 1, 2, 3, and 4, and 5. Nandun rin siya, I think, in the physics classroom. We took these examples in the physics classroom. For example, yung number 1, the same lang naman siya. Same with number 2. For number 2, if you want to draw this one, sige, sample na lang tayo. A rightward force is applied to a book in order to move it across a desk with a rightward acceleration. Consider the frictional forces. So, if this is the table, tapos si book yaong po dyan, tig-move daw siya going to the right. So, if you're going to make a free body diagram out of it, your F applied is going to the right. Friction is going to the left. Mas maliit lang yung friction natin, right? Bakit mas maliit lang or shorter lang yung length ng arrow natin? Because kung mas mahaba siya, ibig sabihin, there's no movement. Ang sabi dito, nagkaroon ng rightward acceleration yung book natin. You have your normal force going upward, and then, of course, you have your gravity going downward. Okay? It doesn't matter kung wala yung normal and gravity, same length lang sila, because if you add more length compared with the other, there's gonna be an effect. Pero dito po, ang tinitingnan natin yung effect, yung applied versus ng friction. And then, where is the book going? So, dapat yun yung mas may emphasis in terms of the length or the magnitude of the lines. Okay? So, just try solving for this one and answering this one. Thank you.